Before we get into the method of unit selection speech synthesis, it would be a good idea to get some key concepts established. What motivates the method? Why does it work? And perhaps what its limitations might be. Let's go right back to how speech is produced. Obviously, speech is produced in the human vocal tract, and therefore the signal that we observe, the waveform, is a result of several interacting processes. For example, when the tongue moves up and down, this isn't perfectly synchronized with the opening of the lips, or the opening and closing of the velum, or the bringing together of the vocal folds to start voicing. Each of these articulations is loosely synchronized and can spill over into subsequent sounds. That's the process known as co-articulation. And so the end result of co-articulation is that the sound that's produced is changed depending on the context in which it's produced. Not just the sound that came before, but also the sound that's coming next, as the articulators anticipate where they need to go next. That's an articulatory process, but co-articulation happens effectively at many levels, not just at the low acoustic level inside the vocal tract. There are phonological effects, such as assimilation, where entire sounds change category depending on their environment, and the prosodic environment, of course, changes the way sounds are produced. For example, their fundamental frequency and their duration is strongly influenced by their position in the phrase. From that description of speech, it sounds like it's almost going to be impossible to divide speech into small atomic units. In other words, units that we don't subdivide any further. And strictly speaking, yes, that's true. What we know about phonetics and linguistics tells us that speech is not a linear string of units, like beads on a necklace. The beads on a necklace don't overlap. You can cut them apart, you can put them back together, and perfectly rebuild your necklace. You can't quite do that with speech. However, we would like to pretend that we can do that with speech, because if we're willing to do that, if we're willing to pretend, then we can do speech synthesis by concatenating waveform fragments. And we know that this could give very high speech quality because we're essentially playing back perfect natural speech that was pre-recorded. So the potential is for extremely high quality, and the only catch, the thing that we have to work around, is that we can't quite cut speech into units and just put them back together again in any order. The solution to that problem is then to think about some base unit type, and that those units are context dependent. In other words, their sound changes depending on their linguistic environment. Therefore, rather than just having these base units, we'll have context-dependent versions or flavors of those units. In fact, we'll have many, many different versions of each unit, one version for every possible different linguistic context in which it could occur. That sounds quite reasonable. If there was a finite set of contexts in which a sound could occur, we could just record a version of the sound for every possible context, and then for any sentence we needed to synthesize, we would have exactly the right units in context available to us. Unfortunately, if we enumerate all the possible contexts, they'll actually be pretty much infinite, because context, theoretically at least, spans the entire sentence, or possibly beyond. But it's not all bad news, because let's think about what's really important about context. What's important is the effect that it has on the current speech sound. So let's state that clearly. We can describe the linguistic context of a sound, for example, the preceding phoneme, the following phoneme, and the number of different contexts seems to be about infinite. But what really matters is whether that context has a discernible, in other words, a perceptible effect on the sound. Does it change the sound? And so we can hope that there is actually a rather smaller number of effectively different contexts. And it's that idea that unit selection is going to build on. Let's reduce the problem to something a bit simpler and think only about one particular aspect of linguistic context that we definitely know affects the current sound, and that's the identity of the preceding and the following sounds. This is handled relatively easily because there's definitely a small number of such contexts. And in fact, if we use the diphone as the unit type, we're effectively capturing this left or right context dependency automatically in the base unit type. Let's just spell that out so we're completely clear. This is a recording of me saying the word complete, so we could segment it and label it. And so on. Let's just take that first syllable in red. Let's think about the schwa sound, the incomplete. If we're willing to assume that the effects of the following nasal, the M sound, only affect the latter half of the schwa, we could form diphone units by cutting in half and taking this as our base unit type. And that's the diphone that we already know about. If there are N phonemes, N categories, there are about N squared diphone types. So there's an explosion, an exponential increase in the number of types just by taking one aspect of context into account. Now, while diphone synthesis has solved the local co-articulation problem by hardwiring that into the unit type, in other words, considering left or right phonetic context, it doesn't solve any of the other problems of variation according to linguistic context. And so our single recorded example of each diphone still needs to be manipulated with some fairly extensive signal processing. The most obvious example of that would be prosody, where we would need to modify FCO and duration to impose some predicted prosody. Now, we have signal processing techniques that can do that reasonably well, so that seems okay. What's less obvious are the more subtle variations, for example, of the spectral envelope, for example, with voicing quality, or things that do correlate with prosody. It's not obvious what to modify there, and our techniques for modifying spectral envelope are not as good as the ones for modifying FCO and duration. So there's a question mark there. So let's just summarize the key problems with diphone synthesis. The most obvious, the one that we hear when we listen to diphone synthesis, is the signal processing. It introduces artifacts and degrades the signal. That's a problem. However, there's a deeper, more fundamental problem that's harder to solve. And that is that the things that we're imposing with signal processing have had to be predicted from text, and our predictions of them aren't perfect. So even if we had perfect signal processing, even if it didn't introduce any artifacts or degradations, we still wouldn't know exactly what to do with it. What should we use the signal processing to modify? We have to make predictions of what the speech should be like from the text and then impose those predictions with signal processing. Unit selection is going to get us out of all of these problems by choosing units that already have the right properties. And the way that we'll get them from the database, the way that we'll select them, will be an implicit prediction of their properties from text. We'll see that later. Let's pursue the idea of diphones for a moment. Although it's too naive and going this way won't actually work, it will help us understand what we're trying to do. Let's try hardwiring into the unit type all of the linguistic context. So instead of N phoneme types, giving us about N squared diphone types, let's now have a version of each diphone in lexically stressed and unstressed positions. Database size will double. But that's not enough. We need things to vary prosodically. So let's have things in phrase final and non-final positions. The database size will double again. And we could keep doing that for all of the linguistic context factors that we think are important. The number of types is going to grow exponentially with those factors. So that's not going to work, but it's a reasonable way to start understanding unit selection. In unit selection, we wish we could record this almost infinite database of all possible variation, and then at synthesis time, we'd always have the right unit available for any sentence we wanted to say. In practice, though, of course, we can only record a fixed size database. It might be very large, but it won't be infinite. And that database can only capture some small fraction of the possible combinations of linguistic factors. For example, stress, phrase finality, phonetic environment, and so on. And from this finite database, we have to make do. We have to do the best we can at choosing units that we think will sound as similar as possible to the unit that we wish we had, if only we had that infinite database. So what makes that possible? What makes unit selection synthesis feasible? The answer is that some, hopefully very many, linguistic contexts lead to about the same speech sound. In other words, some of the linguistic environment has a very weak or negligible effect on the current sound, or more generally, certain combinations of linguistic features in the environment all lead to about the same speech sound. What that means then is that instead of having to record and store a version of every speech sound in every possible linguistic context, we can instead have a sufficient variety that captures the acoustic variation, and we will always find from amongst those one that's good enough at synthesis time. So when we record this database, and we're going to say a lot more about that later on in the course, when we record this database, what we want in the database is variety. We want the effects of context. Because we don't want to have to impose them with signal processing, we want the same speech sound many, many times in many different linguistic contexts and sounding different in each of those contexts. So the key concepts then are to record a database of natural speech, probably somebody reading out sentences, that contains the natural variation that we want to hear, that has been caused by linguistic context. And at synthesis time, we're going to search for the most appropriate sequence of units. In other words, the ones that we predict will sound the best when concatenated. Now, we're going to put aside the question of exactly what's in the database until a bit later, because we don't quite know yet what we want. Neither do we quite know what the best unit size would be. Lots of sizes are possible. The diphone is the most obvious one. Everything that we're going to say is general, though. Whether we're talking about diphones or half phones or even whole phones, all of the theory that we're going to talk about now is going to apply to all of these different unit types. The principles will be the same. So we don't need to decide that at this point. Let's wrap this part up then with a little orientation, putting ourselves in the context of the bigger picture to make sure we see how far we've got and what's coming up. Until now, all we knew about was diphone speech synthesis, with one recorded copy of each type of unit. We'd already decided back then that whole phones, recordings of phonemes, were not appropriate because of co-articulation, and so we made a first-order solution to that, which was just to capture the co-articulation between adjacent phones in the speech signal. That only captures very local phonetic variation, and everything else, for example prosody, had to be imposed using fairly extensive signal manipulation. What we're going to do now is we're going to deliberately record the variation that we want to be able to produce at synthesis time. Lots of variation, all the speech sounds in lots of different contexts. The best way to do that is going to be to record naturally occurring speech, people reading out sentences, so natural utterances. And synthesis is now going to involve very carefully choosing from that large database the sounds that are closest to the one we want when we synthesize. It's worth just stating the terminology because there is a potential for confusion here. When we say diphone speech synthesis, we mean one copy of each type. When we say unit selection speech synthesis, we mean many copies of each unit type. In fact, as many as possible and as many different variations as possible. Now, the actual base unit type in unit selection could well be the diphone. That's the most common choice. So there's a potential for confusion there.